moment, but I just want to take a moment to introduce Dr. Frank Nagle. We're really excited to have him here today. He's now a research scientist at the IDE, and we're very excited that we just got to poach him from our bitter rivals HBS across the diagonal slope of the river. Frank wears a bunch of hats. He's not only a researcher, but he serves on the board as the chief economist on the Linux Foundation and advises a variety of startups. And his work has been published in lots of leading journals. And he generally thinks about competition and open source in a lot of his research. And I think that some of this might have lines through that today. And we're really excited to have him.
Well, fine. I'll give it to him. Great. Thanks so much. It's great to be here with everybody. I'm excited to present this work. We have an R&R in management science. So now is a great time for feedback and thoughts and figuring out if anybody in the room is one of our reviewers based on so it's joint work with two folks who are formerly postdocs in my lab. Manuel's now a professor at UC Irvine. Sam is a data scientist at the Linux Foundation now. And then also with two folks from Microsoft and GitHub who really helped us with all the data access. You'll see a lot of the data was public, but we actually also got a lot of behind the scenes data from GitHub and Microsoft as well. So normal kind of talk outline, but I'll make sure, do we end right at the top of the hour? Is that?
Or thereabouts.
Thereabouts, okay. Well, I'll try to make sure we leave a few minutes to talk about an extension of this study that focuses on gender. So I won't talk about gender at all in the main study, but then we have a follow-on study. Basically, we didn't know we could get gender information in this setting, and we submitted the first paper to Management Science, and they liked it enough to give us an R&R, and then we're like, oh, we can do this other thing, gender. Usually I try not to slice the data too thin, but in this context, there's a whole another rich story about gender. And so I'll talk a little bit about that at the end as well, which is much earlier stage work. I don't need to do this because it was just done for me, but the only thing I'll add is that prior to the academic world, I had about a decade of experience in cybersecurity. So I still do a little bit of research in that space as well. And on the open source side, I do a bunch of research that thinks about the macro kind of value to society. And more what we'll be talking about today is kind of the micro value to firms, both from using and contributing to open source. And then AI, everybody's studying AI now. My particular focus is thinking about how it impacts companies and also how it changes the way that people work. And today's paper is kind of at the intersection of one and two. So I put the name of this paper into our good friend DALL-E, Generative AI, and this is what it thinks this paper is about. I like this picture and still use it, even though it's a few months old at this point, mainly because only one person actually has a monitor and a computer, and the top two people are sitting inside the desk. So AI, it's not fully there yet, but as we all know, it's already kind of changing the way that we work, right? And so that's what this paper is essentially about, is trying to understand how somebody asked if there is a link to the paper. Yes, it's on my SSRN page. And at the very end of the slides, there'll be a QR code that you can scan that will take you directly to that. I think it's at the top of my SSRN page. So how does AI change the nature of work at the very high level? More specifically, we'll think about how it changes task allocation, so how people allocate their time and the tasks that they do in the context of open source software production. And we'll do some things towards the end to argue that it generalizes to a much broader set of kind of information economy types of jobs, not only this kind of narrow specific. And so, I know a few folks have to leave early, so the high level of the paper, thanks Peter for sticking this. This is actually nice, I like this. I don't have to stare at the laptop to see what the comments are in the chat. So what the paper does, we have weekly activity for 2 years, looking at individual people who are sort of the managers of open source. We'll dig into that definitions in a little bit. We have a nice natural experiment here where GitHub rolls out free access to folks that are considered top maintainers, and we'll use a regression discontinuity at kind of the cutoff, and we'll argue that it's as if random assignment to folks around that cutoff. Some folks get free access to this, some don't. And then we can look at what happens to those folks as a result of their usage of this AI tool. The main results are that we're going to see this reallocation of how people spend their time, essentially, how what tasks they do, and they increase what we're calling core work. We'll talk about what that is, and massively decrease what we call project management, which is interesting because the tool itself is really only helpful for core work. It doesn't really help you with doing project management, but we see people increase that for work and decrease project management. We dig under the hood to understand the primary mechanisms that are happening here. And what we see is that more people start working by themselves and working in smaller and smaller teams and less collaboratively, which is interesting because open source by its nature is a very collaborative type of work. We also see people exploring new work that new projects that they've never worked on, and new programming languages and a few other things, and doing less work on the projects that they've worked on before. And then finally, this is pretty consistent with much of the literature in this space, but we find that the impact of all these things is stronger for those that are less experienced or have lower ability or are newer to coding, those types of things. Great, so there we go. I'm new to IDE. What are the norms, or is it leave time for questions at the end, or everybody attack me as we go? Wish. Attack me as we go. That's my, so feel free to ask questions as we go. So our contribution here, there's a lot of great work, including from folks in the room, but on Gen AI and AI in particular, but a lot of it is focused on productivity. How much, faster does this make us? How much does it, increase our productivity and these types of things? And so what we're trying to do here is go beyond the productivity effects, which we can, measure a little bit. We see some of, it's kind of a byproduct of this, but really understand how does it change these people's jobs and what they do and the nature of work itself. We've kind of pulled back a little bit from this second contribution in the reframing of this paper, but we also think about how Gen AI can impact the private provision of a public good, in this case, open source, which is a long-running, a stream in the economics literature. We're a little less focused on that, but I'll talk about that a little bit as well. And then also what we have here is pretty nice because this, I'll talk about this timeline, but this tool and the rollout of it predates ChatGPT, but is built on the same technology that ChatGPT ends up being built on. And so we have this nice, very long kind of 2 years of data, which lots of the studies, that have kind of dug into this from the productivity space don't quite have that length of window. And often it's a bit more experimental. This is more of a real world natural experiment that happened just as a result of the way they rolled it out. So from a theory perspective, I just want to give everybody a little bit of intuition. We all work in the information economy, and we have, we're all trying to do core work, and then all these other things show up that we have to do in terms of project management, right? So in the context of academia, faculty, the core work is research and teaching, and then, hooray, congratulations, you got tenure, you're promoted. Now you're going to stick you on 75 committees and chair of the department and all these types of things that take away your time from core work, right? So this tension is something that we see in all types of information jobs and many other jobs as well. But that's what we're going to study here. And in the context of software developers, especially in open source, we've been able to, some prior work I've done shows that they often spend way less time doing their core work, which we consider coding and actually writing software, and way more time than they want to on these types of project management things. And I'll dig into how we measure this and operationalize this in a minute. But the question here is whether or not Gen AI can, in the context of open source, sort of realign this balance of work so that people are doing more of the thing they want to do and less of the things that they don't want to do. So that's kind of the intuition behind all of this. We did have a formal model with lots of math and figures and all sorts of things. Our reviewers told us to shove that in the appendix, so I'm not going to cover that today. It is in the version of the paper that's on SSRN, so if you want to see that, feel free to take a look.
What's the most important thing we should know about that model and how it influences what follows?
The most important thing is that we can derive the same things from the literature. And so the predictions of our sort of formal model, I guess that's a good question. The most important thing in the formal model is that there's sort of this tension between this core work and project management that for some people, it's more of a complement. And so, these two things go together. And for other people, it's more of a substitute, right? And often that's going to kind of break down along the lines of experience, more junior, less able,
Could we characterize it as an efficient frontier, a tension for creating an efficient frontier?
Yeah, we could think of it that way, right? And so that's one of the main things that's kind of not so much in the literature, but is a bit more in the model, is this trade-off. And for some people, it's more of a trade-off. For other people, it's more of a complement, and they actually go together. And that's, and so that's the main thing. Good question. And so, when we think about that again, the model kind of leads to the same direction with some basic assumptions. But when we think about this core work and project management or managerial work, we expect that the arrival of this AI tool that helps you do your core work is going to reduce the cost of this task and lead to you doing more of it, right? So this is classic economics. When the price goes down on something, people demand more of it, right? And so when it becomes cheaper to do core work, people are going to do more of it, arguably, which is interesting because some of the literature on AI is going to argue that we're all going to have all this free time because AI is going to do our job. As it turns out, economics would predict the exact opposite. We're all going to do more work because it's cheaper and we can do more of it, at least in some contexts. On the flip side, when we think about project management, and this is actually that is left over from the model, that's this complement or substitute kind of measure in the model. But here, the literature has less to kind of predict about this because often management is less of a routine task, right? And so it's harder to automate and automation won't always impact it, right? And so it's important to point out here as well that we have sort of a third bucket of work as well. There's core work, there's project management, and there's other. So these aren't mutually exclusive. And so just because one goes up doesn't mean that the other has to go down. It could go either way. As it turns out, empirically, we end up finding that project management substantially reduces as a proportion of all the work that somebody's doing.
Just a thought about the core work and people sort of wanting to do more of it, right?
Sure.
Some of that has to do with the actual productivity and the nature of I've produced code. Some of it might have to do with the experiential aspect of writing software, which may be changed. So I guess in terms of satisfaction in this setting, they might be somehow doing more code writing, even spending more time in activities that can be regarded as that, but that may not solve the problem of feeling like I'm not coding anymore.
That's
all I'm doing
because I'm doing vibe coding. Yeah, so I always point to a great paper of a doctoral colleague of mine, Hila Lifshitz-Asaf, who some of you know. She had I think it was her dissertation paper or her job market paper. She had this great paper looking at when NASA adopted crowdsourcing. And so NASA, we think of super brilliant scientists trying to put people on the moon, all these types of things. But then they adopt crowdsourcing and the ideas, the solutions to the problems that they're trying to solve come in from the outside. Right. And so in many ways to what we're seeing with AI today, it changed the job of these scientists, right? It used to be their job to be the brilliant ones. And now it was their job to sort of, find the brilliant answers outside of NASA, right? And some people love that. And we're like, we're solving problems faster than we could before. And that we have better, newer outside the box solutions. Other people hated it because they felt it was an attack on their identity. And, this is Hila's work, her, of course, it's about identity and things like that. But so I think we could see the same thing here, right? Like that some people are more output oriented and they're just happy they're producing more code and that's a good thing. Whereas some people may be more, we'll say, process oriented and may actually like this a little bit less. And we touch on that a tiny bit in the gender paper, just in terms of the more the genderized nature of some of these tasks, but it doesn't quite get at the do people prefer to do this or not, right? And actually, we're in partnership with the Linux Foundation, we're going to be running a study this fall about a big survey on asking some questions of software developers about how AI has changed the way that they spend their time, right? And so this is, the beauty of wearing multiple hats is the R&R says you need to run a survey and ask people why they're, how they're actually spending their time and how, this changes their time. And then with my Linux hat on, I can say, hey, let's go talk to a whole bunch of developers and ask them what the answer is there. We're trying to do a broader study and not just to answer the questions of our, reviewer 3 in this paper, but I think we can get at some of that through the survey.
Frank, may I ask a question?
Sure. Irving, good to see you.
Yeah,
Again,
I saw
I
you.
was on a call with Irving last night in the context of Linux Foundation.
So, and it has to do with the definitions of programming and project management. So when I read about programming these days, people just seem to refer to writing the code. When I was programming in my young days, I
10
spent
years ago.
most of my time debugging the programs that I wrote.
Yes.
I consider debugging
Yes.
a huge part of programming. I don't
Yes.
know. And so that's one question.
100%. So I'll speak to that more in depth in just a moment,
You know,
but
if your structure of
definitely.
your company is so perfect that you never have to collaborate with anyone to do projects, there's a good chance that you're in a very static space. So this might actually be a somewhat healthy.
Jennifer?
We talk through these things. I won't go too.
Thank you. Excellent. It sounded related, collaboration, work. Maybe that was Siri answering Irving's question for me. So anyways, Irving, yes. So we'll see in this context that, no worries there, Fred, that when AI writes the code, people will often debug it. And does that slow them down a little bit? Yes. But is it still more efficient on the whole? The answer is also yes. And so we'll see, yes, that's one of the things we're going to try and touch upon in this survey is kind of, again, like what has, like that study I was mentioning with Gila, how has the job changed as a result of AI? Are you spending all your time, debugging stuff? And I've heard, at least in the context of open source, that now there's all this, what they're calling AI-driven slop, which is just code suggestions and code snippets, and we'll get more into the details of this, but that are just kind of garbage. And it's actually annoying a whole bunch of people in the open source community because they're all of a sudden spending all their time dealing with this kind of slop and debugging other people's Gen AI written code that they didn't even look at. But that's kind of that's a separate thing that we can dig into in another paper.
And Frank, one criticism I've heard also is that since it's so difficult to know why AI does what it does, because it's a little bit opaque, that makes it harder to debug, because in order to debug, you have to know what the hell is going on. And if AI is deep down in its neural networks, so that's a question. And
I'll add another layer of complexity is that when you have these big giant projects like the Linux kernel or Kubernetes, the cloud stuff, it's even more complicated because Gen AI doesn't necessarily always think about all the complexities of the entire code base. And so it may write something that works, in a vacuum, but then breaks everything else within the broader project, right? So I think these are important questions. And we have a few robustness tests. I'm definitely not going to have time to talk about them, but that look at code quality. And what we do see is that code quality, it definitely doesn't get worse than pre-Gen AI, but it maybe gets slightly better. And so that's kind of the best I can say about quality, at least in our setting. George?
So, beyond the slop side, I'm imagining two mechanisms going on. One would be I'm the kind of person who identifies tasks that need to be done, and I make a list if somebody else doesn't.
Sure.
Now I can do some of those tasks myself.
Yes.
That's one mechanism. The other mechanism would be I'm a coder, but there's always that little thing that I can't quite do. I got to phone a friend.
Sure.
And now I don't have to phone a friend.
Yep.
And both of those would explain this kind of activity. Do you see one or the other happening?
So we haven't checked those directly, but at least sort of tangentially, the answer would be that both of those are happening, right? So we see people putting fewer things on their to-do list or other people's to-do list because the AI can help them do it themselves. And we see, especially in the gender paper, we get a bit more into like mentorship, which happens a lot in these types of communities, but actually, unfortunately, in this particular community, doesn't happen in the case of females, but happens more with males. And so we can see it like Gen AI sort of acting as that phoning a friend and getting help as well. So we see both of those things. We haven't like tested them directly, but anecdotally we see them. Great. All right. So I'll kind of quickly go through the other hypotheses, but again, deriving from some of the existing work, including some of Sanan's, we expect that as this kind of streamlines a whole lot of the processes that happens in this collaboration. To George's point, it kind of we need a bit less communication because we can do a bit more on our own. We're going to see more people doing more work in smaller groups or by themselves and being less collaborative. And then likewise, again, and this sort of goes back to Irving's point, These tools are very good at writing code, not so great at understanding giant code bases and understanding the complexities of other pieces of code that my code is reliant on. And so we expect to see people kind of doing more exploration and trying new things, and less of working on these big, huge projects that require these more better understanding of the complexities of the code. And that's, again, sort of consistent with what the literature says about other IT tech, other IT that has entered into the workplace. And then finally, I already mentioned this, but lots of literature for a long time has said that these types of tools in general, but we've seen already recently lots of studies that AI in particular is going to have a bigger effect on people that are less experienced, less capable, just earlier in their career. And we're gonna expect to see the same type of thing.
I have to ask, how do you define lower ability?
We measure it in 4 ways. I'm sure one of them will make you happy. Maybe one of them. Yeah, totally. Like 100%, it's hard to do, but we tried in 4 different ways, and the results are
Consistent.
slight differences, but very consistent across all. Excellent. I was once told that you tell people it's an excellent question if you have a slide that answers it, and so that's an excellent question. Great. So the setting and data, I've sort of danced around it a little bit, but to test these hypotheses, what we need is somewhere we can observe very granular work patterns and also have sort of the pseudo-exogenous arrival of an AI tool. Where do we find this? As I've already mentioned, the way that GitHub rolled out Copilot in open source ends up giving us exactly what we need. Not everybody loves open source as much as I do, so I'm going to give you a 1-slide quick primer on how open source works. At its core, open source is just software development where you actually make the source code public instead of hiding it away behind the firewall. And the way this usually works, and this is sort of stylized, but this is generally the way it works, is somebody writes a piece of code and they say, hey, this is pretty neat. I want the rest of the world to see it. And so they upload it to a place like GitHub or somewhere else into something that we'll call an open source repository, which is basically just a project folder. It lives there on the internet and everybody can see the code. And importantly, that person becomes what's called the maintainer of the code. And they're sort of the manager of the code, right? And so that's how it starts. That person, as the maintainer, has the right to add or edit or delete that code directly. But the nice thing about open source is that other people can get involved in it as well, right? And there's sort of 2 main ways that other people get involved. One is that they report issues and they say, hey, I found this bug, can you please fix it? Or wouldn't it be great if we had this new feature, can you add it? Or if they're more technically oriented, they can write the bug fix themselves or write the new feature themselves and then submit what's called a pull request. And that says to the maintainer, hey, here's the fix, or here's for that bug, or here's the new feature. Can you please add it to the main code base, right?
But it's always up to the maintainer to.
Yes, exactly, right? That's an excellent question. Maintainers can, there you go. See? So maintainers can choose to address these issues or not. And this is, to Irving's earlier point, like a lot of what's happening now with Gen AI is people are sending these kind of pull requests and they're like, oh, this fixes a bug in your code, but they never look at it and they don't actually understand what it does. And so all of a sudden the maintainers have this flood of kind of suggestions and pull requests and change suggestions that most of them are kind of garbage, right? And so that this, again, separate paper, but many of these maintainers sort of feel that that AI is actually terrible, right? And so there was this small study, I think the N was like 12 people, but we're trying, again, our survey with the Linux Foundation, we're trying to amp that N up, but a small survey found that in some contexts, Gen AI like this actually slows developers down. Like it makes they're less efficient, less productive. We won't have anything to say on that in this paper, but I think, again, broader study with kind of the survey, we may have some things to say.
So I have to ask you an excellent question because there's something you haven't mentioned.
I have a lot of slides.
Okay, good. That my Bayesian fires will update accordingly. On both of these things, so when I was coding after Irving, it wasn't just debugging, it was tests, unit tests.
Yes.
I can ontologically put testing under individual and I can put testing under project management. I can have maintainers do the tests, I
Yeah.
can have the people submitting it because they've done the test and it didn't work. That's why they did the update.
Yep.
Yet you haven't mentioned tests.
Yeah, so that's not an excellent question, because I don't have a slide for that, but it's a very good question.
I'll
So,
settle for that.
the one thing I've talked to a bunch of software developers about this, one thing they love Gen AI for is unit testing. Because they don't want to bother, like, they want to write the code that does stuff, not the code that tests the stuff that they
Right.
already wrote. And so they actually love Gen AI for unit testing, right, for doing these types of tests. I'm trying to think, actually, this is a terrible question because I don't have an answer for it. So in this context, I would presume, and I'd have to double check things, but I presume that shows up as coding because you're writing code to test the other code. Fair point that it may be better to consider as project management, and this is one of the things that we're trying to do now for the new version.
Or a new version.
Is getting a little bit, yeah. I don't think any of the reviewers asked about that particularly, but it's a good question because and we got pushed on and have in the past about like what is the line between project management coding, right? And that's probably exactly the right thing to think about in terms of a gray area in between them, right? And so we've done a few things to kind of swap some things from one bucket to the other as sort of robustness checks, and the results are all fairly stable. But the unit testing thing, I'll make a mental note to have a slide for that next time. And so let's see. So two last things to mention on this process. Maintainers can add other maintainers. So just because you started this doesn't mean you're the only person that ever has these kind of edit and addition privileges. Like Linus Torvalds, who created Linux, isn't the only maintainer of Linux. Just as an example. And the other thing that's important in this whole process too is it's not like Wikipedia where everybody can just go make a change and then ex post the sort of managers say, oh, is that a legitimate change or not? It's the reverse. The managers come in this process ex ante. So I can suggest a change, but it's up to the maintainers to accept or reject that change ex ante, right? So it doesn't go straight into the code. Wikipedia is super important, but it's not gonna, break a whole bunch of stuff if somebody puts some unfactual thing or whatever, right?
And what if there is a conflict between maintainers? Is there like a hierarchy of maintainers?
Yeah, so it depends. There's some projects that are more democratic and they'll sort of vote, and there's other projects that where you have what the benevolent dictator for life, right? The BDFL, who just like that person is sort of like breaks any ties, right? And you'll see that in a lot of projects where, again, like I'm trying to think like something like WordPress that like started as a small project and then sort of became super popular and super widely used. If I recall correctly, the person who started it is the BDFL and can kind of break those.
Resolving conflict is also project management.
Yeah, so in this context, that would show up, and I'll show you how we're measuring this stuff like precisely, but it would show up in the issues page, like those discussions happen in the issues page, and that's how we're measuring project management activity. So it would show up as project management, unlike perhaps your world of crypto where it would just splinter and we'd have to and then it's sort of a different resolution process than we think about in like the crypto space. Similar, but a little bit. Okay, great. And so, open source, I'll keep tooting open source's horn. If you haven't seen this comic before, it's one that like everybody in the open source world shows in every slide deck they ever have. So here's mine of this. But this is kind of the way that modern digital infrastructure works. Every one of you that has a Mac, you're running open source. Every one of you that has an Android, you're running open source. Every one of you that has an iPhone, somewhere in there is some open source, right? So the most recent studies have said that I think it's 96 or 97% of all code bases, like corporate proprietary code bases, open source is in there somewhere, right? So what often happens is we have these like small little projects that somebody created, put out there on the internet, but all of a sudden they took off and they became super important to the overall structure of the internet. And so what happens to these folks sometimes, and we'll go deep into this, is that they get all these feature requests, all these bug requests, and it's only a small project. and they get overwhelmed, right? And so again, the older framing of this paper, we dug more into kind of, can AI help these folks? Here we move away from it a little bit, but I think it's important to mention, because we have this giant public good that some of my other research says is worth $9 trillion to the global economy, and it's reliant on these handful of people that often are overworked and acting as volunteers and all these other kinds of things. If you want, I won't go deep into this story, but if you've never heard about the XZ utils attack, this is a fantastic example of exactly when this type of thing can happen, because there's a small open source project that most of the world's operating systems rely on, and an attacker sort of gets in and puts some bad code in there because the one maintainer was overworked and overstressed. And it just so happened that one other person who was like working on the project a little bit noticed this thing and got to it before the code went into production. But it's a fascinating story, and I'll leave it there, but it only happened like a year ago. But look up XZ utils if you want to learn more about like when this stuff goes bad, right? And how the world can be affected by this. All right, good. So where do we measure all this stuff? We work with GitHub on this. GitHub is basically where open source lives. One of my former doctoral students did a big study on where open source lives, and I think it ends up being 98 to 99% of all open source that's out there today lives on GitHub. So we almost have the whole population of open source when we're looking at this. What's nice for us is that the way that GitHub works, you have this super granular data on coding, project management, and other activities. I'll get a little more into detail on that. But we can see every time somebody does something for coding. We can see every time somebody does something on project management, and we can see when they do other things as well. So if you're not familiar with GitHub, this is sort of what it looks like. This actually is that XZ utils repository. But this, the important thing is up there on your left is it says code. So this is all the folders and the files where all the code lives. And you can think about the only other important word I haven't mentioned yet is commits. And so commits, this is kind of the history of every time a piece of code is added to this project, we call that a commit. And so we can see all the details of the code. We can see a whole lot more granular things than just the commits. And we're gonna basically call anything that happens on this page coding, right? Which is why I would actually expect the unit test stuff to show up in coding and not project management. On the flip side, we have a second tab that's called issues. And this is where all the discussion, all the questions, all the the debates about what we're going to do or not. Here, just as an example, like somebody's asking for a new feature, somebody's asking to kind of pointing out a bug problem here, and somebody's just asking where can I download the latest version of the code, right? And so essentially, this is where all again, we can split hairs and we can move some stuff back and forth between these buckets, but broadly speaking, this is the stuff we're considering project management, and the other stuff is what we're considering code. So now we get to the point where we have to talk about the Gen AI. We're pretty good on time. So Copilot, as I mentioned, it's built on the same technology. It was the first version, and the version we're looking at was built on GPT-3, which is what underlies the first version of ChatGPT, but this predates ChatGPT. And so, as many of you probably know, OpenAI and Microsoft have this deep partnership. You may have heard of Microsoft's version of Copilot. It actually started with GitHub, and GitHub was like, had their mad scientists playing with OpenAI and trying to figure out how can we use this thing. And what they end up coming up with is this tool called Copilot, where it's just next word prediction, like all LLMs are, but it's next kind of code prediction, right? So the way this works, in visually, if you want to write up, say, a Python script that sends a tweet with a picture attached to it, I guess we have to change this to send an X, but so you as the human just write a function header, right? So anybody that's done coding, you kind of start by saying define this function that we're going to send a tweet with an image, right? And then Copilot does the rest, right? So it writes the whole function for you. And so, all the stuff highlighted in blue here, which is all the code itself, is written by Copilot, right? So clearly we can, see that this is going to lower the price of coding. I will point out that, of course, again, GitHub did some studies on this and it's evolved a little bit, but I think about 80% of the time, developers will accept this suggestion from Copilot. Some of those times they'll make a little tweak, change a variable name, make a small correction, but about 80% of the time they accept, most of what Copilot is suggesting, right? So think of, in the background, think of this as what's happening. Later versions of Copilot have more features, which makes things actually a bit messier. So it's actually nice that we're dealing with the earlier version of Copilot that pretty much just does this. All right, so now let's get into the empirical methodology. So just from a timeline perspective, GitHub released a technical preview back in 2021. We throw out the folks that had access during this kind of early stage. And we focus instead on the start in June of 2022 when they roll it out to everybody. So you can get access by paying for it. You can get a trial. If you have an EDU email address, you can get it for free. And we'll use that as sort of a robustness check, but we sort of drop out at least these other ways of getting it for free. And we focus on this program where they wanted to reward top open source maintainers. And so they say, hey, we're going to give you this tool for free to help you do the good things that you're doing for society, but a little bit faster, right? And so we can follow that for 2 years when our data ends precisely 2 years later. And again, we kind of look at these main outcomes of coding and project management that I already described. The way that
I just have a question about sort of what comprises sort of like the body of like the actual open source projects you're looking at, because I know that there are like a lot of like exautils type of open source packages out there where it is sort of like one maintainer or a very small group of maintainers keeping things going, but there are also kind of like open source projects that are actually run by companies, right? So like I'm thinking about things like obviously like Llama is a huge one, but like you have like Elasticsearch or OpenSearch and things like this.
Yes.
And I imagine like
open source is open source is more open, but like I get what you're saying.
Yeah,
lots of these projects are
there's a
that
whole
way.
round of that. But like it seems like to me the nature of the work at like these places, which are basically companies that happen to be running open source projects, would be very different from the nature of work in like these kind of small, like what we traditionally think is open source.
So that's an excellent question. What does that mean? Somewhere I have a slide that answers that, right? So this is the way that we try to think about generalizing to what would happen inside the companies, right? And so we begged GitHub to give us data from like private companies and internal repos, and they said no. And so we were like, okay, fine. But what we were able to do was with their help, map not only the projects, but the individual contributors, right? And so there's some of the other work I've done kind of relies on this more, but there's this big norm in open source. If you're doing stuff as a volunteer on your own time, out of the goodness of your heart, you use a private email address, so Gmail or Yahoo Mail or whatever. But if you're doing it as part of your day job, whether it's your company's code or even like the Linux kernel, tons of companies pay people to work on that. You do it with your company's email address, right? So at Oracle, at Microsoft, whatever the case may be. And so we can actually kind of split out these people that are probably doing it as sort of volunteers and in their own time, and people that are most likely working on behalf of their company. And what we end up seeing is basically the same. Right? Like, so the coefficients slightly different, but the magnitudes and directions are basically the same. And so again, we'll use that as a way to think about kind of generalizing beyond open source, that we would expect similar things to happen inside of companies and not in open source.
And just as a reality check, which I hope is an excellent question, there was no such thing as a low ability top maintainer.
Yes, so that is, yes, there are, so there are some of the projects that make it in here were a little surprising to us in terms of like, so that we can't give precise details on the way they calculated this or kind of the cutoffs that they used, which like is sort of.
You have 4 factors here.
Yeah. So yes, think of, the lower and less experienced, but not necessarily low. That said, I will say we also do some robustness checks with the education group, which mostly, I mean, it includes some of us, but is mostly students. And we find some similar types of things. And there we would argue, or, there's less experience in that bucket as well. But yes, this is, of all of the people, we're looking at, kind of this group, and the lower group is that. That's right. That's totally. So I kind of alluded to this already, but the way they roll this out is they rank all the open source projects that are on GitHub based on a magic formula that We sort of know what they did, but it's not public. They didn't make it public in any way. And then they draw a line. Everybody above that gets free access. Everybody below that does not get free access. They also don't say where that line is, and we know where that line is, but we're not allowed to say that. But the good news here is that we've sort of tested this out and tried to look around. This is a message board that was talking about the rollout of this program. I'll just, I know you can't read that, I'll blow this up. So people were very excited about this program, but as this person says, they're giving it to students and popular open source projects, but what GitHub defines as a popular open source project is sadly not expressly stated, right? And so nobody in the public really understands. They know this program exists, but they don't know how they're ranking them, and they don't know where the cutoff is, which for us as the economist, that's great, right? Like, because it's essentially around that cutoff. You can't game it. You can't kind of get yourself just over it. You can make some educated guesses about what's going into that ranking and try to do stuff, but there's no real way to like be right at that edge and tip yourself over on purpose, right? And so that's again good for us. And so what we'll do is just a standard regression discontinuity. We're gonna again think like the whole stack. We're gonna focus on those people that are just above, just below. We'll look at a few different window sizes on each side. Everything's fairly robust. And again, the identifying assumption here, which we think is fairly sound, is that right at that threshold, the only reason anything that would be happening different, these people are all fairly similar on most characteristics, is because they get free access to code. All right. So then, as I mentioned before, we're going to look at tasks in terms of the allocation. So think about you do 100% of your tasks. How many of those are core work? How many of those are project management? Or what percentage? And what percentage are other? Right. And so we've done some stuff with the raw data and just the counts, and it works too. But it turns out that people in this space it's very lumpy data, right? And so we tried a whole bunch of things, and we're revisiting this in the context of this revision that we're doing. But at the moment, we're sticking with this kind of proportion of all your work and or all the tasks that you do, and what percentage of that is one type of task versus another.
Task or time?
So the survey that we're going to run is going to try to answer the time question. But so one of the problems with, this is just software development in general, these units of measure like a commit, which is kind of again like a contribution of code. It could be one line or it could be a million lines. And obviously, and even that one line could be, again, back to Irving's earlier question, like that could be a line that changes the whole giant project. And so, yes, it's only one line, but it may have taken you, 10 years to write that one. So at the moment, we have, unfortunately, nothing to say about time. Actually, that's not totally true, because we're trying to do time in two different ways, and I won't get into the details because I don't have the time, but yeah, there you go. So with the first way we're trying to do time, and we already have some data on, the results are fairly consistent, right? And so we can think about, are they massively changing their time, effort, things like that. That way is very messy and noisy that we kind of are doing straight from the data. And so our hope is that running this survey that we're going to run in the fall, or nowish in the next month or two, will help us get more at that. And also think about like sort of a range of times, right? So again, like, how much time do you spend on a commit if it's like an easy one or a medium one or a super complex one, and they do some things with kind of bounding and stuff like that.
Because, if you have help from AI and it's actually helpful, you may be doing more commits in shorter amount of time, or you may actually find it so productive that you are doing more commits and spending more time doing more commits. Yes.
And so that's exactly what we're trying to get at, right? And that's, yes, so that will be an excellent question, but at the moment I can't say too. I don't have much to say about it. So the whole panel that we're looking at is almost 200,000 of these maintainers are kind of subject to potential treatment here, and we're seeing them at the weekly level, so that's 6 million. But again, we narrow into around that cutoff. And we look at about 7,000 maintainers and about 270,000 weekly maintainer observations. The last thing that I need to put this on a slide so I remember to talk about it, but it's not just like a one-shot time. So they basically like do this ranking and offering of the free tool. I think it's once a week basically, right? And so if this week you weren't over the threshold, you can't get access. but next week you are, then you get free access the following week, right? And so that's, don't read into this number and think, oh, okay, like, so they must be doing 3,000 above and 3,000 below, or 3,500, 3,400 above and below the cutoff. It's not, that's not how to interpret this number. But we have, again, about 7,000 people that end up being part of this. Half are going to get free access and half are not, and we can kind of track them over time.
But it's somewhat sticky. Does it turn off?
Correct, thank you. It turns off after a year. So,
Okay,
so
I see.
if I got free access today, but then I fell below the line, I'd still have free access for a whole other year. Right? And we can do some things with like looking at only the first year versus the full 2 years and like some other things. Yeah, great question. Excellent. All right, results with we're close on time. So this is kind of the justification for, this is a reasonable treatment. This is the rank. So again, like lower is better, right? In terms of you're a higher rank. And these are the people that are just over that threshold, and these are the people that are just under that threshold. So what we're dealing with here is not a clean, super 0 or 1 if you're above. You can use Copilot because you can pay to use it or get it through your employer or other things. So this is essentially a fuzzy regression discontinuity. But if anything, that sort of biases against our results, because now we've got people that we're sort of treating as zeros, and they're actually, some of them are using the tool, right? But the difference in the way in the usage of the tool is clear, the statistically significant that the people that get the free access through this program are using it more and more. All right, so now we can actually look at the results. So again, think about this as the folks that get free access, what happens to them versus the folks, compared to the folks that don't have free access. So on coding, we see, again, as a percentage of their total tasks, we see them increasing the percentage of tasks that are coding by about, I think it's 12%. And then project management, we see them decreasing by almost 25%. So massive decrease in project management. Again, there's this third bucket of sort of other things that they're doing as well as kind of a baseline. And so this is what happens at kind of the high level. I mentioned we have 2 years of data, so we can track this over time. This is just broken up by quarter, so 3 months of time of what's happening here. Obviously, in the early days, we see people, drastically increasing. This is just coding, and then they sort of level off. But even after, a year and a half, they're still, I think that's like 3 or 4% above baseline. Or above the comparison set. And so they're coding substantially more than those without free access. This is on the flip side, project management. Again, massive drop in the beginning, but we see this kind of leveling off, around 7 or 8% decrease in coding overall. So again, we argue that this is like a permanent effect that happens to people, not just some sort of quick shock, and that yes, it wears off a little bit, but it's still different than zero. Please.
Quick clarification. Is it all maintainers on a project get access because the project gets access?
Yes,
Okay.
that's right. So
There's no
I suppose that's not. So the treatment is at the project level, and so all maintainers.
Okay.
Yes, and so we're actually doing some stuff as part of the revision to look at single maintainer projects, so that we can do it a little bit cleaner, and again, the results are robust, and we're trying to do a couple of things like that. And we also David Otter from down the street was our discussant at the MBER, and he was pushing us to actually write a different paper, but that's his want to do. That focuses on the kind of team dynamic, right? So we don't say anything about the teams here, but how are they reallocating tasks and efforts across the whole team? And so somebody's more specialized or somebody left, and so I have nothing to say about that here, but I think we're gonna do that paper because David Otter tells you to write paper, you do it.
So in that spirit, although I'm not that quality of an economist, there is something missing from the test aspect.
Please.
The people that I talk with who use Copilot and Cursor and Windsurf,
Sure.
yes, they're using it to write code, but they're also using it to get up to speed, to learn. And
That's an excellent question.
Okay, then I look forward to the slide on that.
Sorry, finish, I apologize.
No,
Finish your question.
I mean, it's just that I'm wondering to what extent where your definitions conflate coding and learning and conflate learning
Yes.
how to be more of it. You assume learning, which actually is not what you want to do. You want to have learning be attributed an automation aspect as well as a learning aspect.
Yeah, so that's a good point. I'll have a little, that's almost an excellent question. I have something to say about that because what we see is people experimenting with new programming languages that they've never used before. And I can say something about that. And then also in the gender study, which we'll have about 2 minutes to talk about those results. But we see a little bit of that like learning happening as well. Yeah.
Frank, could I mention something, please?
Please.
That I think of project management in a spectrum. At one end, you have bullshit administrative work, and I can see Gen AI helping that. At the other end, you have software engineering, system engineering. How do you decompose the project into modules?
Sure.
Especially now with the rise of agentic AI,
Yep.
which module should be done by a human, which you can do with an AI agent. That's a very different way of project
Yes.
management, correct?
So I saw some recent study, and I need to start citing it directly, but somebody sort of ran a study of programmers and asked them how much of their time do they actually spend coding, in this sort of pre-AI world. But these types of folks only spend about 40% of their time actually writing code. The other 60% is doing what you're talking about like thinking about the architecture of the code and like plotting stuff out and like understanding how the whole thing works. And so I think that, to that end, I'm not here to say that like more coding is better and less project management is better. Like that's not like, I don't know that I have a strong like statement.
Well, there are two different jobs.
Yes. Yes.
That's what it comes down to. Sinan, I don't know if you agree with me. I know you've been thinking a lot about agentic AI, but agentic AI feels like system engineering to me.
Yeah, I don't have anything that is going to be that additive right now, but I have a lot of thoughts about what the implications of this that are sort of like too far reaching to talk about right now. So yeah.
Great. Yeah. So in the interest of time, I'll press on. So surprise, our other hypotheses, we find evidence to support them. Autonomous work, so work by yourself or in smaller group, goes up. Collaborative work goes down, and this is both in the context of coding and project management. Project management, so like most of the work is more collaborative, but there are some things that are less collaborative and people are doing more of that.
I'll stop you right there,
please,
because that's exactly where I was going to go with my comment, which is that we also find in some of our work that this sort of coordination between humans goes down.
Yep.
Because now I can just do it with the AI and I have less opportunities to do the coordination. And I guess in the back of my head, as I see your study and our work and other people's work, I'm wondering what the secondary or third order level implications of that lowering of collaboration is for serendipitous things that might be very beneficial that won't now happen because we don't need to have a conversation about something
that would also conversation. So I 100% agree. And actually, this is like, I guess I said I didn't take opinion, but actually this is like my most worrying like finding of the whole thing is that, engineers, software developers, we're all like, everybody in this room, we're all nerds and we don't like to talk to people anyways. And now we're like giving people a reason to talk to people even less, right? And that's like, this concerns me, right? And so I think that as we think about more of the like, the broader implications of the technology as a whole, this is one we're going to have to, we as like society are going to have to manage, because I think this like reduction in collaboration, yes, it's great that you can do more by yourself, but this may have more long-term implications than kind of.
So unless you have a study about time, we don't know whether fewer conversations are happening. Just because you have done a pesky task quicker does not mean that you don't have conversations about things that actually are more likely to generate some higher quality.
And so my hope is that we can answer that with the survey, right? Because again, we're going to try and ask people how much time they spent on a variety of tasks before using Gen AI and then after using Gen AI. And this, like, maybe we find that they spend, they're doing more coding tasks, but maybe they're spending less time coding, and they're doing fewer project management tasks, but maybe they're spending more time talking to people. Like, my guess is that's not the case, and like, but we may be able to at least shine some
I
light.
have to ask, this is what, based on empirical stuff. I see many gray market communications and Slack and stuff
Sure.
like that, and and particularly referring to your corporate accounts, they're not making that public.
Yes.
That's internal. I'm just wondering, is that a ghost in your?
Yes.
Okay.
It's unobservable, right?
Okay.
And I guess you would have to believe, which you could believe this, but you'd have to believe that Copilot shifted people either away or towards Slack and the kind of ghost communication, rather than the communication happening through GitHub in the issues discussions, which is the way that it sort of the formal communication.
If you get accused of slop, you have an incentive to go.
To go offline. Yeah, that's a fair point. Yeah, no, that's a good point. I'll think about that more and whether perhaps the survey, we can ask a little bit about that too. Yeah, that's a great point. I'm gonna skip these more granular measures just in the interest of time. But not only do you do fewer of the things that require you to collaborate, when you do anything, this is the number of average collaborators on the project that you're doing stuff with. Almost all of the tasks that you're doing them with smaller and smaller groups as well. So it's not only that you're not like talking to the people you already talked to, you're doing new stuff. As this kind of shows, you're doing more exploration on new projects and less exploitation on old projects. And this stuff seems to be happening more in smaller groups, right? And so that's kind of the way to tie these two together. So more exploration, less exploitation. This is the answer to the question on new skills and learning. So this is just a standard kind of regression on programming language exposure. On average, at the baseline, people are working on 8 or 9 kind of programming languages, which actually sounds a tiny bit high to me, but like in open source land, I can kind of believe that. And then for the folks that get free access to Copilot, they increase that by 1 or 2 programming. Wow. Hang on to that wow in a second, because what we did then is we actually tied this to a Stack Overflow ran a survey a few years ago on developer salary by language. So people that do Python get paid more than R or something like that. And we actually find that people are moving towards better paying languages as well. So it's not just
Shocking.
right, it's not shocking, right? So there's rational behavior happening here. And then with a super back of the envelope calculation, for the like full sample, we estimate that this could increase their labor market potential by about $500 million. This is definitely not like a general equilibrium, and obviously if everybody moves to the same language, then that salary is going to drop. But just to give some like sense of kind of put a dollar figure on here, we're at business school, we have to put dollars in here somewhere. This could have a very large, meaningful effect for kind of skills enhancement and learning and things like that.
On the new languages effect, do you find any difference in like the H1 hypothesis effect, like magnitudes by different languages, the products? Like let's say
we haven't looked at that.
Let's say Python versus a very obscure language.
Great question.
Yeah.
We can not an excellent question because I don't have an answer, but great question. We can look at that, right? We can check it by that's a great question. We haven't done that. That's a good idea. All right. Low ability versus high ability. Again, we measure it 4 different ways. How central you are to the code. This kind of achievements or badges that you get, the number of followers you have on GitHub. None of these are perfect. And then this is just how long have you been active on GitHub. But none of them are perfect, but all of them are the same. Coding goes up way more for the folks that we call, are below the median, lower ability, and way less for higher ability. And project management here, the scale is negative, so 0's over here. So high ability drops less than low ability, as we would anticipate. Again, consistent with all the work that we've seen. This is, I already talked about this, the firm versus non-firm. So again, when we kind of split people based on, are you most likely working on behalf of your company or not? The coefficients slightly different, but pretty darn close, right? And so we see, fairly consistently, whether you're working for a company or as a volunteer, you're increasing your coding and you're decreasing your project management. Definitely not going to have time to go through this. I mentioned the quality effects. On average, code quality doesn't go down. It probably goes up slightly. And then again, we do some stuff with the student access. The results are fairly consistent as well. Conclusion, there you go. And women in tech is a super small percentage already. In open source, it's even smaller. It's like 5% of top contributors from this study from a few years ago. Despite, well, not despite, but like in spite of the fact that open source, the phrase was coined by a woman who's an MIT. And so then lastly, so what we do here is we based on name prediction using 4 different methods, we assign genders to people in open source. And we kind of cross-validated with some people who do report their gender, and so we've cross-validated with self-reporting. And so we end up with sort of, again, the same type of study around the cutoff. We end up with about 4,000 people we can identify their gender, and about 16 and 17% in our final sample are female. And so what we can see is actually start at the bottom. We'll have to rearrange this, but everybody, women and men, try Copilot, right? So there's no major difference. The light green is male, the dark green is female, and the blue is the difference when you take female minus male. Everybody tries it, females a little bit less, but not statistically different. But when you look at actual usage and how intensely they use Copilot, women are using it way less. This is consistent with, some of you know, Rem Koning, down, my old colleague. He's run a kind of global survey and found similar results. But what we're able to do now in this context is then say, come back to these measures of behavior change and see what happens despite this. You know, we know there's a difference in adoption. When you adopt, what happens in your behavior change? And so here, this is the increase, you know, same stuff we just talked about, increase in proportion of coding. This is men and this is women. So women way more than men. I think it's like 5 times more than men increase the proportion of activity that is coding. And likewise with project management, here it's not quite as dramatic, but this is men and this is women, and this is the difference. Women almost twice as much decrease their project management. So we're, again, this is early days, but we're digging into some of the mechanisms. We're able to rule out a couple kind of mechanical differences or skill differences. And what we end up you know, finding some evidence that we're trying to dig deeper into is that AI here is acting as a mentor in a place that is notoriously hostile towards women, which, you know, again, I love open source. This is the least thing I like about open source, is that it's not a very friendly place for females, and in a variety of ways. And in particular, this lack of mentorship for females. And so we think what's happening here is AI is being used as sort of a substitute for human mentorship. And additionally, this, you know, there's this whole literature in econ, Claudia Golden kind of did a lot of it, but that shows that women do tasks that are less promotable and are kind of less like noticeable. And so what we're finding some kind of suggestive evidence for is that women are doing more project management in these types of things already. And therefore AI is allowing them to actually, you know, I wouldn't say act like men, but do more coding and do less project management because of this trade-off that we found in the other study. So that's it. You know, there's the QR code to SSRN. Sorry, we're late, but we started a few minutes late. All right, thank you so much.